Hello, myself Pranita. I am from CSC AI and ML. Today topic is incidence matrix in network topology. Let's see what is an incidence matrix. First of all, let's see how to draw a graph for an electric circuit. Consider the following electric circuit. In this circuit, there are four principal nodes labeled as 1, 2, 3, and 4, and 7 branches. One branch contains 20 voltage source, another branch contains 4 ampere current source. Then remaining 5 branches contains resistance of values 30 ohms, 10 ohms, 20 ohms, 5 ohms, 10 ohms respectively. Let's see what is a network graph. A network graph is simply called as a graph. It consists of a set of nodes connected by branches. In graphs, a node is a common point of two or more branches. Sometimes only a single branch may connect to the node. A branch is a line segment that connects two nodes. Any electric circuit or network can be converted into its equivalent graph by replacing the passive elements and voltage sources with short circuits and current sources with open circuits. That means the line segments in the graphs represent the branches corresponding to either passive element source or voltage source of the electric circuit. In this circuit, we have one voltage source and one current source. So, according to this condition, the voltage source will be will be closed, will be short circuited, and the current source will be open circuited. Let's draw a graph for that following circuit. This is an equivalent graph corresponding to the above electric circuit as shown in the figure. This graph contains four nodes which are 1, 2, 3, and 4 as given in the electric circuit and contains six branches A, B, C, D, E, and F. In these six branches, the current source is open circuit and the voltage source is short circuit. Let's see how we'll do an incidence matrix following with this graph, considering this graph. The elements of incidence matrix will be having one of these three values plus 1, minus 1 and 0. Suppose if the branch current is leaving from a selected node, then that element value will be plus 1. For suppose if branch current is entering towards a selected node, then the value of that element will be minus 1. For suppose if the branch current is neither leaving the selected node nor entering the selected node, then that element value is 0. Follow these steps in order to find the incidence matrix of directed graph. Select a node at a time of given directed graph and fill the values of the elements of incidence matrix corresponding to that node in a row. Repeat the above step for all the nodes given in the directed graph. Let's see what a directed graph represents. This is a directed graph for the electric circuit given in the before slide. Let's see what is there in this directed graph. This directed graph contains four nodes which are labeled as 1, 2, 3, and 4, and all six branches labeled as A, B, C, D, E, and F. The arrows in this directed graph shows the current branch current direction from one node to another node. The branch is a line segment joining two or more nodes. A node is a common point between many branches. The incidence matrix corresponding to the above directed graph will be as shown in the figure. Let's understand how did the plus 1, minus 1 and 0 values are entered in this incidence matrix. Selecting one node, we'll select first node. At first node, branch current A is moving towards the node. So the value of that element will be minus 1. At node 1, branch current B is moving away from the node. So the value of that particular element will be plus 1. At node 1, the branch current C is neither moving towards the node or moving away from the node, so the value will be 0. At node 1, the branch current D is moving towards the node, so the value will be minus 1. At node 1, the branch current E is neither moving towards the node nor leaving the node, so the value will be 0. At node 1, the branch current F is neither moving towards the node nor moving away from the node, so the value will be 0. So like this, we can write an incidence matrix for all the nodes in the directed graph. Since this directed graph have 4 nodes, there will be 4 rows in the graph, in the matrix, and there are 6 branches, so there will be 6 columns in the matrix. Therefore, the order of matrix will be 4 by 6. 4 represents the number of nodes of the directed graph and 6 represents the number of branches. Thank you.